Steel is an alloy or mix of mainly iron and carbon. Iron ore is common in the Earth's crust and contains iron chemically bonded to oxygen. It's mined in places such as the Americas, Australia and Scandinavia, and then shipped to steelworks around the world. Ores from different sources are blended together to produce a favourable mix, which is then combined with coke and heated to produce the iron-rich material called sinter. Sintering reduces waste and produces an efficient raw material for the blast furnace. Carbon is also required for the blast furnace process, and this is supplied in the form of coke. To make coke, coking coal is heated in an oven. This drives off volatile byproducts, leaving carbon. The gas produced in this process is used as a fuel, whilst other byproducts such as tar, benzol and sulphur are extracted and refined. These raw materials, sinter, iron ore and coke, meet each other at the blast furnace, where they are fed into the top of the furnace along with a further ingredient, limestone. A hot air blast, from which the furnace gets its name, is injected through nozzles called tuyeres situated in the base of the furnace. This blast raises the temperature in the furnace to white hot intensity, around 2,200 degrees centigrade. This extremely high temperature is needed for the chemical reduction and melting of the sinter and iron ore to form a pool of molten iron in the lower part of the furnace, just above the hearth. The limestone that's been added combines with impurities and forms a liquid that floats on the surface of the molten iron. This is known as slag. As the molten iron is tapped from the furnace, the slag is skimmed off and taken away for use in other industries, such as road building and cement manufacture. The molten iron, or hot metal as it's known in the industry, is still impure and contains unwanted elements such as sulphur, phosphorus, manganese and silicon. To make steel, these elements must be removed or reduced, and other elements added, depending on the type of steel being made. The carbon content, at about 4%, makes iron very brittle and unsuitable for rolling or forging. And although iron can be used for castings, most of the iron produced is processed into steel. There are two main methods used to produce steel: basic oxygen steel making and electric arc. Basic oxygen steel making, or BOS, is the main bulk production process for refining iron into steel. BOS vessels can take up to 350 tons of molten iron at a time and convert it into steel in less than 30 minutes. To start with, scrap steel is deposited in the vessel. Then the hot metal, which may have been pre-treated to remove elements such as sulphur, is added. A water-cooled lance is lowered into the vessel and high-purity oxygen is blown through the lance at about twice the speed of sound, just above the surface of the hot metal. The oxygen combines with impurities and this oxidation produces heat. Temperature is controlled by the quantity of scrap steel and by the addition of iron ore, both of which act as coolants. The oxidized carbon creates carbon monoxide gas, which can be collected, cleaned and used as a fuel. Lime is added as the oxygen is blown, and this combines with other oxidized impurities to form slag. The quantities of scrap, hot metal ore, lime and other fluxes are precisely calculated to ensure correct temperature and composition of the steel. Refining can be assisted by injecting argon, nitrogen or oxygen through the base of the vessel, and a sublance is used to measure carbon and temperature during the blow. This allows final adjustments to be made. During tapping, the steel composition is adjusted even further by alloy additions. At this stage, the carbon has been reduced from around 4% to about 0.05%. Finally, the vessel is tipped to remove the slag for recycling. After the BOS or EAF steelmaking processes, a combination of secondary steelmaking processes is used to make further refinements to the steel. These specialist processes are designed to improve consistency of temperature and composition within the steel. They facilitate the removal of gases such as hydrogen, the reduction of elements like sulfur, and the addition of alloys and slags. These processes provide additional controls to ensure the steel meets exact customer specifications prior to casting. Continuous casting is the process used to solidify the molten steel ready for shaping into a huge range of final products. A ladle of steel is teamed or poured through a gas-tight refractory tube into a tundish. The tundish is a reservoir that allows the steel to flow at a controlled rate through further gas-tight refractory tubes and into a series of water-cooled copper moulds. With only the outer shell solidified, the steel is drawn from the bottom of the mould through a curved arrangement of support rolls and water sprays. It emerges horizontally in the form of a solid steel strand. At this point, it is cut to length using automatic gas burners. Depending on their size, these solid shapes are called billets, blooms, or slabs, and are now ready for shaping into finished products.